Welcome to Unit 2. In this unit, we're going to be discussing right triangles, everything you ever wanted to know about them. I would have to say that this unit and the one on Intro to Trigonometry are the two that are most applicable in your other levels of math and on things like the ACT and the MCA test. Give this unit and the next one a little bit extra attention. They're quite important. So first of all, something you probably already know is the Pythagorean theorem. So let's go draw ourselves a little picture of a right triangle. And on a right triangle, we always have a right angle. The two sides adjacent or touching the right angle are called the legs, and the longest side, the one opposite of the right angle, is called the hypotenuse. But in math, when we get wordy, we like to assign variables to our words. So the legs, the ones touching the right angle, are called A and B. It doesn't matter which one's which. They're just each a leg. The hypotenuse we always call C. And Pythagoras, a famous Greek mathematician, he's actually kind of a weird guy, had a whole group of people who followed him, kind of like a cult. They were called the Pythagoreans, and they were weird. Anyway, he discovered that a squared plus b squared always has to equal c squared. As long as the triangle is a right triangle, that's in the hypothesis. If a triangle is right, then a squared plus b squared equals c squared. Well, a converse switches the if and the then. So it says if on a triangle a squared plus b squared equals c squared, then you get to say that the triangle is a right triangle. So we've got two things going, but both of them are very similar, and you've probably done them before, so we're going to kind of go a little faster through this section, but I'm just finding this missing side. I know that a squared plus b squared will equal c squared, because if the triangle is right, then the Pythagorean theorem holds. I just need to replace those variables. A and b are interchangeable, but x must go in for c. It is the hypotenuse or the longer side. So I'm going to say 4 squared plus 3 squared, or 3 squared plus 4 squared, because addition is commutative. That sum will be the same regardless of which leg I put in for A and which one I put in for B. But again, C always has to be locked and loaded in that longest side across from the right angle. 4 squared is 16, never 8. 3 squared is 9, never 6. And that's what has to equal x squared. I sum these up, giving me a sum of 25. And to undo a square, I do its inverse operation, which is to square root both sides. And that's how the Pythagorean theorem always ends. You always end up square rooting both sides. So I get x is equal to 5. Technically, algebraically, x could be plus or minus 5, but since it's representing the side of a triangle, we say it has to be positive 5. So my next question is this a right triangle? Well, now I'm going to use the converse of the Pythagorean theorem. That says if a squared, one of the legs, plus b squared, the other one of the legs, equals c squared, which must be the one across from the possible right angle, then I say yes. So that's a question mark waiting to be answered. 9 times 9 is 81. The square root of 115 squared, these are inverse operations, so the root and the square cancel each other out, and I just get 115. If you don't believe that, try it. The square root of 4 squared would be the square root of 4 times 4, which is 4. You'll notice the end result is these inverse operations just cancel each other out. 11 times 11 is 121. Are these equal? Well, clearly not. The left-hand side is so much greater than the right-hand side. So is this a right triangle? No way. A squared plus B squared did not equal C squared. Now we'll do in 2.2, we're going to still do the Pythagorean theorem, but we're going to combine it with our concept of area. The area of a triangle is, let's discuss the area of a triangle for a second. Don't write this down. I'm going to go off to the side. You should have learned a while back that to get the area of a rectangle, you do base times height or length times width. Well, you'll notice the triangle is a half the area of the parallelogram that it sits in. So if the area of the parallelogram is base times height, then the area of the triangle is 1/2 of base times height. So the base on this is 7. The height to that base is unknown. You can call it X or H for height or A for leg. You can call it anything you want, but I need to go find it because it needs to go and replace the height variable in my formula. So off on the side, what I'm going to do over here is I'm going to go figure out what is H. So I would say, and let's call it H. Let's go do that. I'll make it a little clearer. I would say that leg squared plus leg squared equals hypotenuse squared. I would say H squared plus 7 times 7 is equal to 9 times 9, which is 81. I'll subtract 49 from both sides. I'm going to get H squared is equal to 32. 81 minus 49. I need to square root both sides to isolate H. So H is equal to the square root of 32. Now you have two options. I will allow you to go to a decimal here, but technically what we usually do is we simplify this root. So you'll notice that 32 has a perfect square in it of 16. So a lot of times we'll replace that with 4 root 2, but just for ease and speed of doing these, I will allow you to go to your calculator, take the square root of 32 and round that to the nearest tenth, which in this case would be 5.7. So now let's go get an approximate. So this is our symbol for approximation. Because I've rounded, it's going to be approximate, but for our purposes, it'll be just fine. So what I'm going to do is do 1/2 times 7 times 5.7, and I'm going to get 19.95 is the area of that triangle. So I had to use the Pythagorean theorem to help me find a missing part. One more, and then this video is done. So on this one, I have another triangle I'm finding the area of. So let's isolate this problem here. And I know that the area, again, is 1/2 of the triangle's base length times the height to that base. Well, I'm missing both of those. I'm missing the whole base length. I have part of it, but I've got to figure out this so that I can get that whole base length. And I'm also missing the height to that base. So I've got two issues here. Which one can I find first? Well, they're both parts of right triangles. Both this question mark, which I'm going to call X, and the height of the triangle are parts of right triangles. But on this triangle over here that I'm putting the dot in, I only know one length. Whereas this one that I'm putting the asterisks in, I know 2 lengths. So I'm going to have to get H first. So I'm going to go off to the side, and I'm going to go figure out what is H. And I would say leg squared, 9, right here, plus leg squared, H, right here, has to be equal to hypotenuse squared, which is 17. And then we'll go use our calculators. Probably don't need them for 9 squared, but you might need it for 17 squared. So let's go do that. And we get 289. We're going to subtract the 81 from both sides. And we get 208, so I get H squared is equal to 208. And again, to undo a square, I square root, and we will round to the tenths. The square root of 208 is approximately 14.4. So that's what's going to go in for my height. So I've got 1/2 base times height. Well, I now need to go get the base length. So let's go back over here. I'm going to erase this. I'm going to put in my 14.4, or the root 208 would keep it more exact. And I think I like doing that better. So I think, because here's my h, it's a square root of 208. Let's go throw that on there, and I'm not going to even simplify it. You'll see why. So for me to find the base length, I'm going to go erase my workspace over here for height, and I'm going to go show some work for finding x, because I need it. So I can add it to 9, so I can replace that sum right here. So in order for me to find x, I'm going to say it's squared plus 16 squared is equal to the height, which was square root of 208 squared. Notice again, these undo each other. So I get a nice x squared plus 16 squared is 256. Oops, Mrs. LaRue. Sorry, I violated my own. Sorry. This is the, and I'm not going to remake this video. I'm just going to start again. I had the hypotenuse in the wrong spot, which is deadly in the Pythagorean theorem. Remember, you always have to lock and load that C across from the right angle as the hypotenuse. So I actually have x squared plus the square root of 208 squared, right, is equal to 256, because that's what 16 times 16 is. Let's get rid of the 208 by subtracting it from both sides. So I'm going to have x squared is equal to 48. For me to figure out what x is, I'm going to take the square root of both sides. And again, I will allow you to go to the tenths, but kind of know you would usually in a higher level geometry class, you would have to simplify this and call it 4 root 3 and keep it exact. But I'm going to allow you to go decimal and just take the root of 48 and round it to the tenths, which is 6.9. So x is about 6.9. Now, I don't go put that in for the base because, watch me erase this, this right here is 6.9. So the base length that I'm going to use is going to be 6.9 plus 9, or 15.9. So now I'm ready to do 1/2 of the base times the height. So these are a little bit more involved. And you'll need a calculator, either online or you can come grab one from me. And the area of that triangle ends up being about 114.5 if I round to the nearest tenth. And you can stop and you're going to go work on worksheets 2.1 and 2.2. If you feel like you kind of got it down and you're really good at it, I might ask you to do a few scattered and let you skip some. So again, if you're listening to the video, after you do a few, just say, do you think I know this well enough? Can I move on? And I may or may not say yes. So have a good one.